Imagine you choose something what is today cheap. You have your capex under control. But what people sometimes don't see is the TCO, the total cost of ownership, for 25 years. So what can be cheap today can have like extra OPEX for the next 25 years. Many investors, many EPCs I've seen, they're under huge price pressure that they care today for the lowest price, and they shift the problem of this extra cost of tomorrow to tomorrow.
Andreas, good morning. Welcome to the show.
Good morning, Peter. Good to be here.
Nice to have you here. So, Andreas, I have an interesting question for you based on your activity on LinkedIn. So you had a post which was titled 15 Years, 15 Dawns that actually gained a lot of traction in LinkedIn. Why do you think that it hit such a nerve in the solar world?
I think everyone who was on site have seen at least one of the points. And you see the points over and over again. And I think people couldn't stop themselves just to share their story, what they have seen on site. Yeah, I was actually surprised about the feedback I've received. And I received also from people like they are top 15 or even top 100 points.
Wow, that's a long list of things that can go wrong. And obviously, coming back to your experience, you spent 15 years in EPC, and you've seen all of these mistakes and all of these pitfalls in the book. What's the first project that really taught you the right way of doing things and how things can go wrong?
It wasn't my project, but once I was called to a project to India, and it was back in 2011. Could have been anywhere in the world, but that one was in India. It was planned, it was designed. They went to the site, and then they learned the hard lesson because they didn't do a ram and pull out test. So they had no idea about the soil, and the soil was hard like granite. So there was no piling possible. There was even no cable trenches possible. So they had to redesign the whole plant. We had to pre-drill, put concrete, and put a pile, and all the cables that went like above the ground with cable channels. But there was still one crossing to do because there was like two sites they had to cross, and then we had like a special machine, like on a truck with a jackhammer, but like a huge one. The thing was busy for 1 week just to make a 5-meter trench. You plan something nicely, and then the real world hits you.
It sounds like you actually had to put a rooftop project on a ground mount soil, right?
Yeah, you could say so, yeah. And, that was challenging because this project was in nowhere. And now we needed, 500 cubic meter concrete. That was the mission to get.
That's crazy, but I think that's always nice to be able to adapt to the situation that you're dealt, right? Because sometimes you're planning, everything is nicely laid out, but it doesn't always correspond to the real world conditions of the project.
Exactly.
And when it comes to these kind of issues, what would you say is the best way of avoiding having these type of situations?
Well, proper planning. You have really to go out to the plant, to the site, check the site, speak to the people on site, do all your testing. Many companies just try to shortcut and say, okay, we have done it 100 times, so it will go well. But you need really to go and do the ram and pull out test. You need to go and do some soil excavation just to see all the layers and don't hit any surprise. I mean, there was another plant in Germany, in Bavaria, actually. They said, it's fine. We go 160 ramming depth. We started the first pile. It didn't go in. Second pile, till number 10. We only had 10 like bended piles. And what we found out then, there were like rocks everywhere, 80 centimeter below. There was a 6 weeks delay and a lot of cost.
If you count those losses, right, the people standing, the machine standing, and then you have to redo the whole project, that's an insane amount of money and finances lost.
Absolutely. And you're out of control. When you plan it, and we know that planner reality is always like a story, but if you plan it properly, you're somehow in control. But if you just take chances, you lose the control over the project, you lose the control over your cash flow, etc.
Yeah, of course. And I mean, those margins are being squeezed today more and more. So it's quite crucial for you to plan well, to maintain your margins as well, and don't hit huge capex milestones before they need to be hit, right?
Absolutely. I mean, we see it actually race to the bottom. We see the prices are dropping everywhere. IPPs are under pressure. PPA prices are dropping. So everyone is actually turning on the price screw, and margins now are razor thin. So you have to make sure that you actually, as I said earlier, are in control.
And you mentioned IPPs and PPAs. When it comes to these type of arrangements, how do you see the landscape changing in terms of flexibility and when you actually need to produce during the day?
Well, what we see is now like supply and demand. The supply is bigger, especially during midday. Some countries we see negative pricing. In some countries we see curtailment. And that hits the investor actually when the performance should be as at best, midday. So I think we cannot just like install PV south-faced. We need to look at other solutions. West-east could be the first one, but I think in the long term, it only works hybrid with BESS.
And when it comes to east-west and south-facing projects, especially on large ground mount, I've seen the tendency this year that we are installing more and more trackers, even in Germany. What do you think about that? Is that the solution, or we should just be doing better planning and better yield analysis ahead of time?
That's a great question. Maybe a bit of both. Whatever you plan today, even if you to have a plant which is with BESS in 5 or 10 years is a completely different business case. What you do today is like the peak shaving. You just push to the afternoon, and in the afternoon you make maybe the money. But in 5 or 10 years, it could be just a standard practice. With a tracker, even in Germany, yeah, you have the full cycle of the sun the whole day. And if you put BESS also on top, then you're really in full control, let's say 24/7. And that might be actually the future, which we maybe see in 5 to 10 years, a tracker and a BESS, maybe even with wind together and some other solutions like clipping, for example. Many people, they go for the maximum grid connection, what they need. Let's say they have a 50 megawatt plant, they go for 50 megawatt grid connection size. But what about going with 40 or 30 and just sacrifice the other? That could happen that you actually get a grid connection instead of not having a grid connection.
And what is your take on the hybridization of projects? So is this the right way that we should stack wind, solar, and the batteries together, or whatever it's available, so we can cover the day cycle, right? So we can also produce at night, or maybe we can plan in other ways as well, and that's more flexible and more kind of the real answer to a longer term solution.
I think what we see often is like there's a wind project or there's a PV project when we look at the existing infrastructure. But solar, everyone knows there's no energy flowing in the night, or with wind, there is not much wind during the day. It's more during the night. So if we share more often to go for the cable pooling, I think we can actually overcome the bottleneck which you see today with the grid. Today, we have 1,700 gigawatts of renewable energy waiting to be connected to the grid in the European Union. And we need to find a better, smarter solution just to combine everything.
And again, that's 1.7 terawatt. So that's a ridiculous amount of renewables waiting in the pipeline. We have the planning for it, but we don't know how to execute on those well, right?
Well, we know, but there is a grid upgrade we need to wait. And then we have the application which is pending. And then you have like every DSO or TSO have his own way to run the application. Some are quite modern. They run with IT. Some are still on paper where you just print out your application and send by post today in 2025.
And what do you think would be the right solution or the right formulation for this?
I think communication, we need to harmonize it. DSO, TSO, they need to talk to each other. We need perhaps a database in Europe, not only in Germany, even Germany don't have, but even in Europe, that we really see what is going on with the different DSOs. Just in Germany, we have almost 900 DSOs, and DSO A and DSO Z, they don't know what they're doing. They're not talking to each other. They even not talking to the TSO. So that is also separate. And I think we have to find solutions from the IT side and also from the communication side that we generalize actually the application and the planning ahead.
But I guess all of those guys have slightly different motivations and slightly different incentives. So what would be the right answer? How do you align these people to, strive for a common goal?
That is a good question. And if I know, I'll tell you.
Okay, that's a good enough answer. Andreas, you've been in the industry for a long, long time, and you've seen. You actually wrote about the flip flops on the site and wrong cabling in the ground. What's your experience with that? Like, is it lack of training, or is it just the pressure of churning out the project really quickly?
I think it's a bit of both. It is always a cost pressure. And with the cost pressure, what you do, you choose the cheapest supplier, the cheapest subcontractor. And the cheapest subcontractor don't have the budget to train its people. Or the cheapest subcontractor just take the workforce, which is available today, but they're untrained. They may be first time on a solar plant. You are just stuck with all the issues also in the long term, because whatever you do wrong in execution, live with that for the next 25 years.
25 years is a long, long time. You actually mentioned somewhere along the lines how expensive the cheap solution can get, right? Can we expand on that?
Well, just imagine you choose something what is today cheap. You have your capex under control, but what people sometimes don't see is the TCO, total cost of ownership, for 25 years. So what can be cheap today can have like extra OPEX for the next 25 years. Many investors, many EPCs I've seen, they're under huge price pressure that they care today for the lowest price, and they shift the problem of this extra cost of tomorrow to tomorrow.
And I guess it's kind of two two-part scale. On one hand, you as the EPC, you want to win the project, so you need to present a reasonably priced offer. On the other hand, you're not really incentivized to what's going to happen in 10, 15 years down the line, right?
Exactly. And in financial models, in an Excel where you plan your cost, to explain the quality, the minimum quality, it is hard to put this in numbers. There's just always a pressure from the revenue side to hit a higher margin, but especially on that side, there is just a pressure for price reduction, but there's now thinking about the quality and perhaps the issues in a couple of years. If you choose the wrong or cheap component whatsoever, and it breaks in 5 or 10 years, a technical engineer knows this, but not the finance guys maybe. And if it's replaced in 5 or 10 years, the finance guy actually, they wouldn't know it.
Wow. And how is that minimum quality typically defined on a project? What are the kind of KPIs, or what is the structure of defining these type of metrics?
Well, normally a proper or a serious EPC have a list of suppliers which are like qualified, and they going through the list. But there might be some other EPC that just go purely for the price. Because sometimes if I go for a tender and I get different prices, there's like huge price differences, and I wonder like why. And when I deep dive into it, then I can see because they choose maybe a cable from any country in the world without certification, and the other one is like taking maybe in Germany produced cable. It is hard to compare then, because you're not comparing apples to apples when you have such a wide spread of the quality understanding. And that is hard to explain then actually to the finance guys why you want to go for the more expensive solution.
Before the show, we were talking about the MC4 connectors. You mentioned that this is a classic example. You can pick one with no patent, slightly higher resistance, or you see suddenly losing the real yield. So how is that implemented when it comes to larger plants?
I think that one is so underrated, this issue, because it's such a small plug, and you just like crimp the cable, connect it, and then you put it together, and then it click. But it doesn't mean it's a certified pair. You have like Stoibli, who invented the MC4 plug, but there is no patent on it. And then you have a lot of aftermarket solution. And if you have like brand A and brand B, maybe one of them is Stoibli, maybe not, even if they fit, but the geometry it can be a little different. And then it is not like connecting very well. You have like a higher resistant, and the higher resistant will lead to heat, and heat means loss. So you will have on every string yield loss. It can be 1%, can be 2%. But if it goes very wrong, you can have even a hotspot and a fire on site. And then that is a real bummer because the insurance wouldn't pay because the pair wasn't certified.
So there are quite a lot of things I want to drill down on here. So first thing, the certification. What are the best practices when it comes to acquiring the right certified parts, and why is that worth it on the long run?
So what you need to do when you buy PV panels, you need to talk to the supplier which plug they're using. You need to get the data sheet, if it was a Stoiby plug, which most go for, or if not. And if it wasn't a Stoiby plug, you have to find this company and buy the counterpart. Some PV panel suppliers are also send you the right plugs with the panels, but not everyone is doing it. So you just have to make sure from beginning that your plug which you purchase and connect to the PV panel is exactly the same brand.
Do you think investors and engineers truly understand how a few connectors or cables can cost them hundreds of thousands of euros every year?
I think it depends. If you're talking someone who is a long time in the industry, they know it. But the industry is becoming bigger. There are more and more people coming in, and I meet more and more people which are just have like a few years experience, and maybe they not came across this issue. Not everyone knows that the MC4 plug on left hand and another MC4 plug from different brand on a right hand is maybe not a certified pair. So that comes with experience, I would say.
And do you also feel that sometimes the engineers and the financiers have a really different view, and they really are fight between each other of like how the project should be done?
Yes, I mean on the finance side, they don't go into this detail like an MC4 plug, but the engineer does, and maybe the procurement does. But as said, it is hard to explain why you need higher capex, how you explain them. You need to go for this quality for long term. The pressure on the investment side is like we go as cheap as possible with tier one, but there's anyway quality differences.
Yeah, and sometimes tier one is just a stamp, right? So it doesn't really reflect on the actual quality. You can get the tier two, and maybe it's a slightly better quality than the tier one has been, right?
Exactly. Just because they're not in a Bloomberg list, maybe they don't have the turnover, but they might have the quality. And maybe they have the quality and a bit more expensive, and this is why no one is buying, and this is why they're not in the list. It's a game to find, I think, the middle way between good quality to make the plant last for the 25 years or 30 years, and pay not more as necessary.
And coming back to the Bloomberg list, I actually spoken to a friend of mine in China, and he said, the Bloomberg list is really just a branding exercise. So if you do have good suppliers, you can find them either in China or somewhere else as well. But the Bloomberg list is actually just a pay-to-play type of model. And if you have the personal relationships of acquiring the hardware, it's actually much better and much more cost efficient for you to do so.
Absolutely. I'm completely with you. It's maybe the first place to go if you're new in a game and you want to understand which companies there, but you need to go into the quality check, the audits, and certify actually them as a supplier.
So, and guess then we are back to the money part, right? It will take you a lot of time, cost you a lot of labor hours and money to get those certifications done. So it's quite a tricky decision to make.
Absolutely. But most companies only calculate the project cost on a project. The overhead costs are not integrated in the project cost. So the overhead cost is paid somewhere else.
And do you think there is the solution to this? Like how would you redesign the EPC bidding process to kind of shift it towards more of a quality-driven process instead of the cost-driven one?
That is a difficult one because it is depend what is the mindset of the asset owner. Some just building it up and selling it as soon as under operation. and some are building it and keep it to the day until it's getting decommissioned. It's a difficult one.
So I guess if you're building your own house and you're going to live in it, you pay more attention to it. But if you're just building it to flip it, then you're not going to focus so much on the quality, right?
I think that is it, because if you construct and connect, and the business aim is to sell it to someone, you're very price driven. But if you operate it yourself for 25 years, then maybe you're more quality driven, especially when you're longer on the market and you know the pain and the headache. If you was cutting corners in the beginning.
For sure. And as we mentioned before, cutting corners might come back and bite you in the butt later. Do you have any examples do you have any examples of maybe countries or developers that are actually getting these things right?
I think if you look at industry nations, or if you look at the Nordics, for example, I think they're very quality driven. Their mind is very quality. Other, especially countries where they're new in a market, where they have like local EPCs, they're not there yet with their experience. I think especially markets which are long in the game, they understood now how important it is to look at the quality. Because we see a lot of plants 10, 15 years old, where they already consider repowering because it's not performing anymore because of so many issues they have with the quality.
So I guess the short answer is the further you are on the learning curve, the better decisions you make, right? Which is obvious. So is there any way to fast track these for those countries or geographies that are new to the business?
I would say to buy in, whether in outsource or insource, from experienced companies, experienced consultants, experienced countries, just to listen to them and getting like to consult you what to do and what not to do.
For sure. And you actually mentioned that some of those panels are already coming back, right? After 15, 20 years of life cycle. So if we look at the project from the end point, so once the panel is done and it has lived its life cycle, what's the take on recycling? You mentioned the other day that we are somewhere along the region of 70 to 90,000 tons of panels that should be coming down soon. Are we prepared for that in Europe, or what is the right approach to address this?
Well, maybe let's clarify. First of all, you have to recycle. You cannot just landfill it or export it. You can only export it, let's say, for a second life if you have certification. The panel is tested and good to use, then you are allowed to export it. Otherwise, you are forced, actually, inside the European Union to recycle it. Amount which we have today, we have the facilities inside the European Union, but this is scaling up fast. You say today we have 70 to 90,000 tons, but just in 5 years' time, in 2030, we're gonna have 300,000 tons, and further the line is going quickly up. So I think it's like a chicken egg. The industry is there. There are players preparing, but the capacity is not there yet because there's no that demand yet. But I think that the demand will rise, also the capacity will rise.
It's already mandatory, right? And let's talk about the cost side of these things. So it costs about 2.7 euros per panel to recycle in Europe, right? And sometimes it can be $10 to even $20 somewhere else. Is anybody budgeting for that at the design stage, or what's the approach?
No, I'm afraid no one is budgeting for it. Every financial model, every CapEx planning I've seen, the decommissioning was not part of it. And I think that is a dangerous game. You mentioned already the price of the PV panel. Yes, 2.7 euro. It is somewhere there. I've seen prices in the US where they cost up to $18 per panel. And this is why maybe we see so much landfills in the USA, which will not happen in Europe. And also what many people believe, that if they decommission the plant, the material cell after recycling will cover the cost. But that is not true. If you only look at the PV panels, you have like the cost per ton, 50 euro plus minus, but the income is 110 euro with today's market of glass, aluminum, silver, etc. So there is a gap. And you as an asset owner, when you have to decommission the plant, you need to pay the gate fees. And the gate fees need to be money for it.
It always comes back to money, right? And what happens if people ignore this? Like who will pay the bill at the end of the life cycle?
I think, the card game Black Peter, whoever holds the last card, so the last asset owner. Of course, the last asset owner can go back to the supplier because the supplier is actually obliged to take care of recycling by European law. But in 25 years, who knows if the supplier still exists? And the supplier is mostly not inside the European Union. So it's really hard to go for it. So you need to do it. But in case there is no last owner, or even is a foreign owner of the PV plant, I'm very concerned it will go down to the DSO or to the landowner or maybe in the end to the taxpayer. Otherwise, maybe we have a lot of stranded assets in the European Union.
Also, we don't want to end up in the same situation where we ended up with the coal power plants and maybe the nuclear ones as well, that the cost is bared by the public.
It should be asked already by the lenders, and it should be maybe also part of law that the decommissioning is already planned with a building permit, for example, that when you present your calculation how much a kilowatt hour costs, the LCOE, that everyone asking, is the decommissioning already part of this calculation? And is mostly not.
We should focus on like front loading these type of requirements, and then everything should in principle solve itself.
Yes. Why we only look at the start of the project, but not the end of the project? I mean, it is a project because you have a start and an end. And the end is just blurred away.
That's very true. And where do you see the biggest errors or blind spots in today's thinking when it comes to the modules, construction, and maybe how we measure the success of the project? So both in terms of recycling and generally, what are the kind of typical measurements that we look at?
I think the proper design, the proper execution, and already that the plant is also designed for the decommissioning. You can already plan it during the design phase for the last day. For example, if the foundation is a bit tricky, everyone is running to the solution of using concrete. But this concrete, it will be so difficult to take out when you decommission the plant. I've seen where we went for a second or third ram and pull-out test for further static calculation to find a solution where we just can go for ramming instead of using concrete. I think concrete is a real killer on the project, especially when you consider decommissioning. For example, also transformer station. Many people go for it already, but a containerized solution where you can just go there and hook it up with a crane instead like a concrete station, which is built into it, it is so hard to decommission.
So should we avoid concrete as much as possible in most cases, or what is the right rule of thumb?
We should stay away from concrete as much as possible when we build PV.
Makes sense. And what do you think are the kind of signals that the industry should pay more attention to before it's too late when it comes to the construction?
Yeah, the proper execution, the quality in execution, and have a minimum training level for all the labors. For example, if I would be the investor, the asset owner, I would, for example, have an owner's engineer on site. Many people just leave it to the construction company or to the EPC company, and their EPC company are in charge for their own quality. It doesn't make sense. And some people say, we have a lender's technical advisor on site. Well, the lender's technical advisor doesn't take any decisions. He just reports what was done in a good way or in a bad way. The owner's engineer in the beginning will take care of your interest to have the proper execution on site and can also decide on site which way to go.
Yeah, it's difficult to make decisions on the spot, right?
Well, if you don't have the owner's engineer and you get your monthly report, you just see what have been done. But with the owner's engineer on site, you can steer it already from beginning in which direction it goes. So you have the control over the execution. Because once something is wrong installed, whether you pay a lot of money and time to correct it, or you live with this fault for the next 25 years.
That's a big issue. And you actually mentioned labor here a couple of times. Today in Europe, I think the latest number was from Solar Power Europe, around 850,000 people working in solar. But that number is going to increase exponentially in the next couple of years. What do you think is the right way of training these people, and who should train them?
For example, I went to South Africa. It was for them a complete new market, but there were some solar schools actually where people could be educated. That was for execution. It was design works. I think we should also look the same in Europe. Many people starting in the industry, yes, they went for their studies in their field, electrical engineering, but not many have really been like trained specifically on the solar side. I know some bigger EPCs doing it, but I'm also afraid that we have a lot of smaller companies and they do not have the capacity to train the people. So they'll be trained like on the fly with all the errors they do while learning.
Exactly. And I mean, it's a big difference to learn something in school and there is another thing to actually do it, right? So to learn by doing, that's typically the most efficient way. But of course, it might cost you a little bit of money in terms of mistakes and other costs. But that's probably the fastest way to get there.
Yes, I completely agree with you.
And we actually spoke about how the construction actually goes. So we were chatting about it makes no difference to build a 1 megawatt or a 50 megawatt plant. What is the kind of methodology, or what are the changing parameters behind that?
In the end, it's the same headache. You have the mobilization, you have to bring the ramming machine. If you do it for 1 megawatt plant or a 50 megawatt plant, it is the same headache. I would say a small plant or big plant, they have like different challenges. Like if something goes wrong on a small plant, you don't have much time to correct it because you finish a 1 megawatt plant so quickly. On a 50 megawatt plant, I think there's a great danger if you have a fault repeated. And then, for example, if you skip your golden table or mock-up table sign off, you might have an issue which you have repeated 100 times.
Is there a fix to repeating those mistakes, or how can we spot them on the fly when we are actually in the process of building?
We come back to the owner's engineer from the asset owner perspective. And if you look at the EPC perspective, to really go for each work you start and to have a sign off. So if you start piling, you do the first 10 piles and you check everything and sign off. Yes, this is a quality we need, or we need to correct it. Same goes then later for the whole substructure with panels, etc., with the DC cabling to build this whole mock-up table and have every stakeholder actually come to this table and sign it off. Some people complain, yeah, it will take time, it will slow us down, but that is the preparation to make it right from the beginning. If you skip this and you're going the fast way and build it anyway, and you have a fault, that is a time problem when you have to correct it 100 times.
We spoke about the timelines in real life. So this is very important, the timeline plan versus the timeline in progress and in the process of construction. How do the aspects such as weather, logistics, and grid affect those timelines once you're actually on the site?
I have seen it so often, for example, that we are planning to start a construction in April because we were told we get a notice to proceed in March because in February there's a financial close. And then suddenly the financial close is postponed for whatever reason. TDD wasn't signed off by the lenders. And now you get the financial close in October. And suddenly your whole project shifted from the summer to a winter construction site in Europe. It depends where you are. You have 6 months of rain and fully moist soil where you hardly can open a trench, or you have like a frozen ground where you cannot open it because it's so frozen and you hardly can lay any cables. And I think especially from the finance side, they don't know this challenges actually to construct PV during the winter time. You're so much more exposed to weather, to the rain, to the frost and whatsoever. For example, you cannot just lay bend a cable when there's 0 degrees because the cable could break.
Yeah, and those are the real life lessons that you cannot learn in school, right? You need to think about that once you actually have a couple of projects under your belt.
Yeah, once you went on a winter site, then you know the pain.
And if you had to pick one of the most important lessons or most important things that every developer should do before they break ground, what would it be?
To really go to the site before, to speak all stakeholders, to check the condition of the land, go to the mayor, to check the grid connection, to do a proper preparation. I've seen where people or companies that just build 100 plants a year, then they start to skip these things because it's just repetitive. Then you have a plant which just have a bad surprise for you, but you don't know because you didn't went to the site. I was once involved in a project where the neighbor, it was on a farm site, the neighbor hated this project. He didn't want that project. And he was doing everything possible to stop us to go to this plant. There were sometimes roadblocks, and we didn't know that before. Not everyone is happy actually for PV.
I haven't heard too many examples like this in Europe, but in the US, it's quite important for you to get the local counties buy-in and the local neighborhoods buy-in as well to your project. But it really depends on which neighborhood you are in, I guess.
Yeah, absolutely. I mean, in Germany or Europe, it's maybe not so complicated like in South Africa. Went also many years to South Africa. There you have to talk to all stakeholders, including the cultural head of the local African tribe. It's not their land, but they've been first there, and they can make your life difficult or easy.
That's quite a wild story. And is there any way to make the grid connection a little bit smoother, or is it still the wild, wild west?
No, I don't think it's a wild, wild west, but I think it's like a bottleneck. Many companies I see, they do the mistake. They just treat the one grid connection from DSO A as a grid connection from DSO B in a different location. But it might be a complete different application. It might be a complete different milestones or deadlines you have to hit. So you have to make sure you read the fine print and actually obey all the rules to follow their application. I've seen delays in years because someone was missing a deadline to submit a document. And also, it's not only follow blindly the process, but also go into the communication with the DSO. Not only meet when something went wrong, no, meet already before, actually to plan with them how to proceed. And also during those meetings, you learn a lot what is maybe not written, but there may be some unwritten rules which they expect from you.
So the unwritten nuances of knowing your customer and doing your homework are of key importance.
Absolutely. And I think it is everywhere, and not only DSO, but especially important with the DSO, because if you don't have the good connection, the rest doesn't matter because your plant will be just a stranded asset.
And if we flip the coin on from the technical to more of the human and the leadership side of things, what do you do when everything goes on site? How do you keep the team calm and still focused on the task?
I think when things go wrong on site, you have to show up, you have to stay calm and do not finger point who was doing what wrong. I think the focus should be on find a solution for the problem. Whose fault it was, that can be checked another day. But first is about protecting the project, protecting the company, and not finding whose fault. To stay calm and just lead actually the solution finding and then execute the solution. If you go there in panic mode, the whole team will be in panic mode, and that won't help the project.
And we've been talking about the management side of things and, how to build a team which nurtures the culture of responsibility and where people are actually fixing the problems instead of hiding them. So that's also a tricky management decision, right? How do you approach that?
Well, what I always tell people, even if you see a small problem, report the problem, and then we look at the problem. Because if you hide the small problem today, it can be a big problem tomorrow. And we better take today and treat it as a small problem with a small solution. But I've also seen that people are sometimes have a fear or scared to report a problem because the feedback earlier was that is not on none of your business or something. So I always try to have this open communication and ask everyone, doesn't matter what you see, doesn't matter what you hear, communicate this, and then we can treat it and see if that is a problem and if you need a solution for it. And rather today than tomorrow.
What advice would you give to new engineers, young engineers who are just about to onboard their first project when it comes to the EPC job?
I would say climb out of your comfort zone, of your comfort box. If you're an engineer, for example, also go to the site. Speak to the construction manager, speak to the laborers when you can, and just see what design means on the screen or what it means in execution actually on a real site. Opposite the same. If you go into execution, for example, and you're on site, also go to the engineering side and look at this. Or also go to the procurement side and check why they order this product and not the other product, which you believe is maybe better. So what I'm saying, should learn to see the full picture and not only blindly your own trade. This will just end up in silo thinking.
If you're looking at the future of the business, the future of EPC or future of building solar plants, do you think technologies such as AI, drones, and digital twins can solve these construction problems most of the time, or will it still be a mostly human-driven business?
I think it will stay human-driven business for a very long time. I know that AI is there. I know AI drones. But AI is not the whole solution. It is just one tool in your whole toolbox. If you have a PV plant and you're constructing it, and let's say the contractor is bending the cables from the panel too tight, the bending radius is too tight, the drone won't pick it up, but the owner's engineer on site will pick it up.
So expertise and experience are the solution.
Yes. It's really good for seeing all information, bringing all information together and seeing the database about it and give you some hints which you maybe wouldn't have seen it just because of the pure amount of information. But especially when it comes to execution on site, there is no AI really there which can take the job of the human. I know there are some automated systems for installing PV panels or whatsoever, but every site is different. It's not a factory where you have this same work, same situation every day. Every project is different.
Is there any innovation that you think it could help to prevent these mistakes that we mentioned in the 15 don'ts from your article?
Not from the AI side. That is like lesson learned. Many people skip the lesson learned. I think we can only learn from the previous mistakes and don't repeat the mistakes in the future. As said earlier, AI is one tool of many, but AI won't prevent you from doing the mistake in the next project again, which you have done in the last project and no one told you.
That's true. That's true. And on a personal note, after decades in solar, what keeps you still motivated to stay in the business and to keep pushing forward?
Well, I want to see Europe actually becoming CO2 neutral. I think we have burned enough fuel. We burn our whole planet. So my aim, my mission is to reduce all this burning, and we are even not halfway yet. So not only Germany, whole Europe need install PV, need install wind, need install BESS, etc. This is actually what motivates me to bring this whole industry, this whole idea forward.
And is there a particular lesson that the industry has taught you both on a personal and professional level?
Yes, I think nothing is how it seems to be. So as said earlier, you plan something, but then every word is different. That was a lesson. You believe something is going in that way, but it's taking a complete different turn.
Indeed, indeed. And if you could give one commandment to all EPCs to follow, what would it be?
Yeah, look at the full picture. Don't go for the cheapest subcontractor, for the cheapest supplier. In the long term, is not helping your reputation. Maybe you win the tender today because you got the cheapest price, but a few years later, if other potential clients look at their track record, they will see that you went always the cheapest way.
We are actually nearing our end of our time. What type of people should get in touch with you? Who would you like to speak to in the industry?
I'm welcome to speak to everyone from the execution side, design, procurement, from the investor side. I mean, in the last 15 years, I was on each side. I was on a construction side. I was in a like IPP side, EPC side. So I have seen the whole picture, the reality on the ground and also the reality in the office. So I'm open to speak to everyone.
What would be the right way to get in touch with you?
LinkedIn on my website.
Okay, so we'll make sure to link to both of those in the show notes below. And Andreas, any finishing thoughts?
Yeah, I want to just say one more thing. Many people lean back when they have like reached the PR, which they have planned. And I don't understand why, because the power ratio you aimed is what the lenders want to see, what the asset owner want to see, etc. But that is just a minimum. It's not a maximum possible. So what I don't understand is that they're not looking into how I can optimize my PV plant and increase the yield and increase my income. This I see everywhere. There's always a debate between we hit the PR or not, but there is not the question, okay, we had the minimum PR. how we get to the theoretical maximum PR. There are some great solutions out there where you can just identify some silent yield killers to optimize your PV plant as its best.
Yeah, that's quite critical. So Andreas, on that note, thank you very much for your time. I really appreciate your efforts and sharing your knowledge. And let's do this again soon.
Thank you, Peter. It was great to be here.